Hi guys, so we are going to do 10.3, which is evaluating expressions. This is the last section in this unit. So we talked about in the last lesson what an expression is. So we know that an expression is using a variable, let's say y, and the coefficient, which is the number that comes in front, plus a constant. That would be an example of an expression. Expression could also be 3y, or it could just be y plus 4. We know that when we have a variable, that is an expression. That is what defines an expression. So we are going to learn how to model and evaluate expressions and make a table of values. So if you take a look here at the keywords, a table of value is a table showing two sets of related numbers. That's the key thing. In the last lesson, we talked about how before we would look at patterns like this, 2, 4, 6, 8, 10. Okay, they all go up by 2. And 7, 9, 11, 13, 15, also going up by 2. But when I say related, we're talking about the relationship between these numbers. So similar in the last lesson, how we looked at the relationship between the white squares and the green squares, or the base and the perimeter with the toothpick triangles like this. That's what we're talking about when we're looking at the relationship between the related numbers. Okay, so here we go. Modeling an expression. So here's an expression, like I said, 2c plus 5. 2c plus 5. That's an example of an expression. In this case, c, remember, is the variable. Something that's variable can change, right? Variable equals change. That's what that word means. So in this case, C represents the unknown number of counters in the cups. So what that means is in these cups, there is an unknown number of counters. We don't know how many are in there. The 5 is the constant and represents these 5 counters that are outside the cup. That 5 isn't going to change. There's only 5 there. But what we don't know, like I said, is how many counters are in these cups. So that's why the C represents the unknown number of counters in the cups. And 2, because there's 2 cups. So whatever number is inside the cup, we would multiply by 2, because there's 2 cups. So one more time, the 2 is the number of cups. The C is the unknown number of counters in there, and the 5 is the constant, the counters that we can actually see. So we're going to look at an example, evaluating expressions using cups and counters. So here's an expression. Once again, we know it's an expression because there's a variable, which is x. Don't be scared or confused when you see x or c or y. It doesn't matter what the letter is at all. So let's see if we can piece this together. In this case up here, there was a 2, and that represented the number of cups. So that tells me here, my 3 is going to represent my number of cups. That's true, I have 3 cups. Now, x. What does the x represent? Well, in this case up here, the C represented the unknown number of counters in each cup. So in this case, the x actually represents the unknown number of counters in these cups. I can't see how many counters are in there. The 2 represents the 2 counters that I can see. So that's how we made that expression. 3, because there's 3 cups. X, because we don't know how many counters are in each cup. And whatever that number is, we would multiply it by 3, because there's 3 cups. And then plus 2, because there's 2 counters on the side. Okay? All right. So, now that we have 3x plus 2, we're going to do the part where we try and plug in a number for x. You're going to be told how many counters are inside the cup. And then you're going to figure out the total number of counters. So, in this case, it says evaluate. Anytime it says evaluate, you're going to be plugging in a number for x. This is very, very similar to when we did our unit on circumference, and we would say pi times diameter. Well, we know that pi is always 3.14, and I told you in this case, the diameter of the circle is 10. You would just punch in 10 for diameter because I told you that the diameter was 10. In this case, I'm going to tell you that X value, I'm going to tell you how many counters are in the cup. So let's look at this example. Evaluate 3x plus 2, that's the same expression up here, when x is 3. So the cool thing about this is all you have to do is now plug that into the value. So we have 3x plus 2. I just told you that x is 3. So when this number is attached to that variable, that's the same thing as multiplying. So we can go 3 times 3 plus 2. Now we know we have to do multiplication first. So 3 times 3 is 9 plus 2 equals 11. Here what they did is they just added 3 together 3 times, but either would be okay. So here we can see they're showing us there's 3 counters in each cup, and if that's the case, we add them up and we have 3, 6, 9, 11. The next question shows when x is 4. Same thing. If I put that in, 3x plus 2, 3 times 4 plus 2. 12 plus 2 equals 14. If there's 4 counters in each of the cups, I have 4, 8, 12, 14. That's what it means by evaluate. We are putting in the value. They're telling you how many counters are in the cup. Here we didn't know. We said it's a question mark. Here they're telling you if x is 3, if there's 3 counters in each cup, how many are there in total? If x is 4 and there's 4 counters in each cup, how many are there in total? So all you're doing is plugging in the number for x into that equation. Okay, you try. So here's the time for you to pause. Draw cups and counters to model the expression. Remember, the first number represents the number of cups. The variable represents the number of counters in the cups. And the 4 represents the constant, the number outside the cups that can't change. So go ahead and pause the video and give that a try. All right, so hopefully you paused the video and now you're back. So we're gonna go through this together. So I know that that 2 represents that there are 2 cups. The y represents that there's some number of unknown counters in those cups. So I'm putting a question mark. And I'm gonna put plus 4. There's 4 counters on the outside. That doesn't change. So hopefully you got that all by yourself. We are now going to look at evaluating, substituting into the expression. So that's very similar to what we just did right here. When I told you that x was 3, so that meant that there were 3 counters in each cup. We're going to look at a different example here, and I'm going to give you an expression and tell you what x is. So here's our expression, 3x plus 2. So what do I mean by that? A scenario where I have 3 cups. X represents that in these cups they have an unknown number of counters, and 2 is the counters that I can see. Okay, so here we have 3x plus 2. So 3, this is a different way to write it. You can do it either way. 3 bracket 3, that just means 3 times 3. That's a different way of writing it. So you can see here I've done that. 3 times 3 plus 2. So what I'm saying to you is when there's 3 counters in each cup, so let's pretend, for example, we can see that there's 3 counters in each cup. 1, 2, 3, 1, 2, 3. You're probably thinking, well, Mrs. Buer, why can't I just count them like this? 3, 6, 9, and then add the 2 is 11. You can, but when it gets more complicated, you're not going to want to draw out all the cups with the counters. That's why we're going to use this method of doing it. So, looking at the expression, I'm telling you that x is 3. So you'll notice I put 3 in right here. So then 3 bracket 3 means 3 times 3 plus 2. 3 times 3 is 9, plus 2 is 11. So if I count that up, that's the case. 3, 6, 9, plus 2 is 11. Now we're going to look at the exact same expression, 3x plus 2, that's the same as this. But let's say I tell you that there's 4 counters in each cup. Same thing, all you're going to do is substitute in the x, 4. Substitute in the x, 4, that's funny because it is a 4, for the for the letter. So x is 4, I'm going to put 4 here. That means 3 times 4 plus 2. So 12 plus 2 is 14. If I'm not sure, just as you're learning, you could draw it out. So that means I have 3 cups. My constant, sorry I ran out of space here, I'm going to do it here, is 2. Inside the cups I have 4 counters. Let's make sure we got the right answer. 4, 8, 12, 14. Okay, so that is what that means when we say evaluate expressions. We're putting in that number for x, saying that's how many counters are in the cup. Okay, your turn to try. Evaluate expressions. Substitute into the expression. So here's your expression. 2y plus 4, you are going to substitute that in. So when you see y is equal to 1 here, you're going to put that into the equation just the same way that we did up here. Follow these steps. So go ahead and pause. All right, so hopefully you gave that a try. So here I have 2 and now I see a y. Well, y is equal to 1. So I'm going to put in a 1 plus 4. 2 with that 1 in there is the same thing as 2 times 1 plus 4. So 2 plus 4 equals 6. Next, let's try it when y is 3. 2 times 3 plus 4. 6 plus 4 equals 10. So hopefully you got both those answers, and if you did, awesome, good job. If you didn't, go back and rewatch this part again. Next step, make a table of values. So table of values, to review, we looked up here. That's when we have a chart and we're looking at 2 sets of numbers in each column, okay? So let's scooch back down and give that a try. Look at the pattern of squares. It can be described using the expression 2n plus 1. So they're telling you that 2n plus 1 is kind of like the rule for this pattern. That's how they're going to keep increasing. So let's take a look and just kind of look at the pattern ourselves. So the first one I can see has 3 squares. The second one has 5 squares. And the third one has 7 squares. So I already kind of see a pattern happening. And they're telling me that 2n plus 1, that is like the pattern for these figures. So it says, what does 2n plus 1 represent? So they're telling me that n is the figure number. So look, here's figure number 1, figure number 2, figure number 3. Figure is just a way to kind of say like the picture. So what does 2n plus 1 represent? 2n plus 1 represents the number of squares, right? Because that's what I did here. I counted the number of squares. 2n plus 1 is basically like the pattern for the squares that we're seeing. So as you can guess, now we're going to use this information, this 2n plus 1, to figure out maybe how many squares figure 60 would have or something like that. We're not going to take the time to draw out all those diagrams, and that's kind of what's different about grade 7 than maybe some of the other grades. You might have drawn out the different ones and been asked, what would figure 6 have? Now we're going to be looking at a number that's further away, which is why we have to be able to use that 2n plus 1. So First step, make a table of values. Make a table of values for n. Remember, n is just the figure number, and 2n plus 1. So use numbers 1 to 6 for the figure number. So we've got figure number 1, 2, 3 here. Figure number 2 had 5 squares. We already figured that out. Figure number 3 had 7 squares. So I do see a pattern happening here, but for me to figure out figure number 4, I can just plug it into this formula. So I'm going to go 2n plus 1. The figure number is 4, and that's n. So what I'm going to do is 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. Okay, so my suspicion was right. This is going up by 2 every time. So in this case, I don't actually have to keep doing the other ones. I can just fill in the rest. If this was 9, this is going to be 11 and then 13. So I've filled in my table. Now is going to come the question where I might say to you, okay, how many squares would figure number 60 have? Or something like that. Okay, here it is. How many squares will be in figure 30? Well, I'm not going to just extend this table and keep skip counting. That would take way too long. That's why all I have to do now is use this expression and plug in whatever figure number. They already gave me that information, figure number 30. N is the figure number. So what I'm going to do is 2n plus 1. That's my formula. Then I'm going to plug in 30 for the figure number because that's the one I want to figure out. So then I'm going to keep going. 2 times 30 plus 1. 2 times 30 is 60. Add 1 is 61. What does that information mean though? That means there's going to be 61 squares in figure 30. Okay, that's what the question is asking us. Let me just see. Okay, let's try another one with this one. How many squares would be in figure, let's say 15? Figure 15. Pause the video and give it a try yourself. Okay, so hopefully you tried that. So hopefully you wrote out 2n plus 1. Now I have figure 15, so I'm going to put in 15. 2 times 15 plus 1. 2 times 15 is 30 plus 1 equals 31. What does that mean? Figure 15 has 31 squares. Once again, if I had made that whole table out, that would take way too long. That's why now in grade 7, we have to be able to put that information in using that expression, right? Here's my expression, 2n plus 1. They told me that's my pattern. Now all I have to do is plug in the information. Okay, you try. There's 2 questions here that you can try. Pause the video. It's the exact same type of question, different numbers. And when I say line segments, what I mean by that is for this first one, figure 1 has 1, 2, 3, 4 line segments. A line segment is a line in between the 2 dots. Okay, so good luck. Give it a try. All right, so hopefully you pause the video and you've given this a try. So my first figure is a number of squares. So in figure 1, there's 1 square. And the number of line segments is 4. In the second one, there are 1, 2, 3, 4, 5, 6 line segments. In the third one, there are 1, 2, 3, 4, 5, 6, 7, 8 line segments. I instantly see a pattern here, 4, 6, 8. It's going up by 2 each time. If you're not sure, draw the next one. Never a problem to do that. So here's 4. So there's 4 squares. How many line segments? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, well now I'm confident. The number of line segments goes up by 2 each time. I can see that pattern there. Okay, so I know that figure 5 is going to have 12 and figure 6 is going to have 14. That's great. That's perfect. I've got my table. Now I'm going to ask you, how many would something that's not on the table and it's quite far away have? Well, we have our formula here. They've given it to us, 3s plus 1. That's like our magic pattern. How many line segments would be in figure 12 of this pattern? Well, I know that all I'm going to do, that everyone matches up, right? Figure 1 had 1 square. Figure 2 had 2 squares. Figure 3 had 3 squares. So figure 12 is going to have 12 squares. So 3s plus 1, the s actually stands for the number of squares. Well, and I know figure 12 is going to have 12 squares. So I write out my formula, 3s plus 1, 3 times 12 plus 1. 36 plus 1 equals 37. What does 37 mean? It means that figure 12 is going to have 37 line segments. Okay? I'm going to scooch down a little bit. I'm going to give you one more example here to try using the same formula. So if my question was to you, using the same formula, how many line segments will figure 20 have? Okay, well, figure 20 is going to have 20 squares, so I'm just going to pop it in. 3 times 20 plus 1. 3 times 20 is 60 plus 1 equals 61. So figure 20 will have 61 line segments. All right, well, hopefully that went okay for you guys. As long as you know that if you have that pattern, no matter what it is, if it's 2, whoopsies, if it's 2x plus 6, if I tell you that x is 2, you can figure that out. That's all you need to know, is how to plug it in into that expression. Very important that you do your textbook questions so that you get feedback. Look at your answers, make sure you're doing them properly, and then you can complete the workbook online. Awesome job, guys. Keep working hard.